Okay, let's go ahead and get started here. So today we're going to be going over two-step equations, how to solve them. This is our first set of notes for Unit 3, solving two-step equations. Up until now, we've been solving one step. Guess what? You can do it just like Sierra, one, two-step. So go ahead and start by putting your name and your class period. I'm going to pretend like I'm first and fifth for this set of notes. Don't worry, second and third, I'll get you guys later. Okay. So we are going to start with what is an equation. We have gone over this many, many times. I'm sure we are all very comfortable with it. An equation is two expressions with an equal sign in between. All of these are equations. And remember, we do have different ways that we can write multiplication. This means 8 times 3. This means 7 times 2. That one means 4 times C. And this means 2 times H. Go ahead and pause if you need to get your notes caught up. Okay, inverse operations are operations that undo each other. They're also the opposites. None of that should be new information. So the inverse operation of addition is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse operation of division is, you guessed it, y'all are so smart, multiplication. Go ahead and pause the video if you need to get caught up on those notes. Okay, this guy right here is what we're going to be working on this unit. This is essentially how to solve multi-step equations, kind of an order of operations, if you will. Although we're used to this order of operations, aren't we? Parentheses, exponents, multiplication and division, adding and subtracting. However, remember, when we're solving an equation, we're looking for ways to undo things. So we're kind of going backwards, aren't we? So if you look at this, this actually almost goes backwards. We're not going to work with this top part for today. We're only working with these bottom sections. But it does go backwards of what we're used to. So we're used to doing multiplication and division first, and then doing adding and subtracting. However, when we're undoing operations, we're going to work backwards. So we're going to start with adding and subtracting, and then do multiplication and division. So we're used to PEMDAS looking like that, but today we're actually going to go in that direction. Go ahead and catch up your notes if you need to. Okay, let's get after it. Oh my goodness, can she do it? I don't know. Let's see. So example 1. Y'all know I have to have my right color. Okay. Example 1 says 4x plus 2 equals 42. I know my first step, you guys guessed it, is to draw my gate. So now I know that I've got two sides to my equation. I'm also going to put up here to remind myself that I'm looking for adding and subtracting first, and then I'm going to look for multiplying and dividing. So our goal is still to get our variable by itself. So I'm going to look on the side of the equation that has the variable, and I'm going to see, is there anything in here that I could add or subtract that would start to get the variable by itself? See if you can figure it out. This is the part where I feel like Dora the Explorer. You guessed it! I can get rid of this plus 2, and I use the inverse equation or inverse operations to do minus 2, minus 2. So my first step on this one was to subtract 2. These cancel out. We're familiar with that. Now it's not just our x coming down, it's our 4x equals 42 minus 2. Great job for Desmos. I'm going to tell you it's 40. Okay, so now we have 4x equals 40. Remember, this means 4 times x. See if you can remember, how do I undo multiplication? Great job. See, don't I sound just like Dora? So you're going to go ahead and divide both sides by 4. I know, like, y'all just cringed and paused the video and gave up, didn't you? It's okay. You'll be okay. So to do this, we are familiar with this guy too. Our 4's cancel out. Our x comes down. We have x equals 40 divided by 4. Great moment for Desmos. Also, you could just say it's 10. Remember, you can always check this by plugging this 10 back into this side with the variable. So I could say 4, I'm using 10 instead of x, plus 2. If I put that into Desmos, just like it is, and it gives me 42, then it's correct. And I'm going to tell you guys, it is correct. So I'm going to put Desmos should equal 42. Okay. Go ahead and pause there if you need to get caught up or work around on that one at all. And then hit play when you're ready for example 2. Okay, example 2. Let's see. Remember, we're looking for things that we can add or subtract to get our variable by itself first. And then we're looking for things we can multiply or divide. That's a D, not a B. I'm so sorry. Okay. So first off, let's draw that gate. We love it. We know we love it. Okay. Do you see what we can do first? We can subtract our 4 from both sides. So these guys cancel out. Our 6x comes down. And then 70 minus 4, that's a great moment for Desmos in your life, or you're lucky, I'm going to tell you, it's 66. So our first step here was to subtract 4 from both sides. So now I have, remember, this is 6 times x. Does anybody know how I could undo that 6 times x? You are correct if you said divide both sides by 6. Cross out these 6's. X comes down. This is a great moment for Desmos in your life, or you could just listen to me and I'll tell you that it's 11. So our second step here was to divide by 6. So first step, subtract 4. Second step, divide by 6. Oh my gosh, guys, I forgot to write my second step on the last problem. So on example 1, quick reminder, my second step was actually to divide by 4. Whew, it's a close one. On this one, to check it, just like we did last time where we substituted our value into our original, we're going to substitute 11 in for x. So we have 6 parentheses 11 plus 4. If you put that into Desmos, see if you know what it should equal. It should equal 70. Okay, go ahead and pause there and get caught up on example 2 if you'd like. And then push play when you're ready for example 3. Okay, example 3. Okay, remember I'm going to look first for anything I can add or subtract to get my variable by itself, and then I'm going to look for anything I can multiply or divide. Draw my gate. Variables on this side. I need to look for anything I can add or subtract. I think we're getting the hang of this now, aren't we? I can add 2, because this is a -2, so I can add 2 to both sides, because the inverse would be adding. These cancel out. My 4x comes down. 4x equals 42, 43, 44. And our first step here was to add 2 to both sides. Okay. See if you can figure out what the next step is. You got it. Divide both sides by 4. Whew, that was cheesy, Miss McNabb. It's okay. So if I divide both sides by 4, that does get rid of that x right there. Or I'm sorry, that y. The x comes down. So we have x equals, doesn't get rid of the y either, Miss McNabb. That's next semester. It gets rid of my 4. Whew. Gets rid of my 4s. My x does come down. 44 divided by 4, great moment for Desmos in your life. Or I can just tell you that it is 11. So my second step on this one was to divide by 4. And to check this one, you could put this side into Desmos, and it should equal that side. So to check it, you could just put 4, open parentheses, 11, minus 2 into Desmos, and it should equal 42. Okay, go ahead and get caught up on that one and press play when you are, or hit pause if you need to get caught up, and then press play when you're ready to go ahead and get started. Last but not least, we made it. Example 4. 6x minus 4 equals 62. Remember, we're looking for things we can add or subtract first, and then we're looking for things we can multiply or divide. Okay, let's draw that gate. Let's add, oh, look, I've got minus 4, so I can plus 4 to both sides. That 6x comes down. 6x equals 62, 63, 64, 65, 66. I have 6x, so I can divide by 6. That x comes down. Ooh, forgot to write my 6 there. 66 divided by 6, wonderful opportunity for Desmos in your life, or you could just say it is 11 because Miss McNabb told you so. Hey. So on this one, my first step was I added 4 to both sides. And my second step was I divided both sides by 6. To check it, you guessed it, I need to plug 11 in here, and it should give me 62. So we've got 6, parentheses, 11. See how that works into timesing it? Minus 4. If I put that in Desmos, it should equal 62. Okay, got some great examples here. I do want to kind of look at this. So remember, we talked about we needed to look at our order of operations for this is going to be, we're undoing addition and subtraction, and then we're undoing multiplication and division. Let's see if we looked at it. We undid subtraction, and then we undid addition with subtraction, and then we undid multiplication with division. So we got it, right order. We undid subtraction, or we undid addition with subtraction. We undid multiplication with division. Got it. We undid subtraction with addition. We undid multiplication with division. Got it. We undid subtraction with addition, and we undid multiplication with division. Got it. So we did all of our steps, addition and subtraction first, and then we looked at multiplying and dividing. We did not multiply first, and we did not divide first. Never once did we start by dividing this 4 out. We started by getting rid of anything that was adding or subtracting. Okay, so you do have some practice here. And I do have a hint. If you missed any of these notes or need any other help, there will be a copy of my notes in the Unit 3 folder on Schoology. Have fun. Good luck.